So we have learned what binary search tree is and why we need it. In this lecture, let's see what is the common operations that can be performed on a binary search tree and how can we create a binary search tree using linked list. So in case of binary search tree, we can perform the following operations on binary search tree. So these operations are like this: creation of binary search tree, insertion of a node to the binary search tree, deletion of a node from binary search tree, searching for a value in a binary search tree, traverse all nodes of binary search tree, and deleting entire binary search tree over here. So the first operation that we are going to perform is creation of binary search tree in terms of linked list. So here all we have to do, we have to create an instance of binary search tree that we created. So inside constructor, we are just setting the root node to null, because in this case we don't have any element when we are creating binary search tree. Then by using insertion method, we can insert as many as elements that we want to our binary search tree, because here we are not setting any limit to the number of the elements. So when we are implementing binary search tree in case of linked list, we can insert as many as elements that we want to insert. Now let's head over to Java and create our binary search tree class over there. Now here, first we are going to create a class for binary node. So I'm going to create a new file over here and name it binary node. Then inside this file, we are going to create a class for binary node. So I'm going to declare our class like this: public class binary node. Then inside this class, we are going to declare left child, right child, and the value of the node. And we are going to create an extra variable over here in which we will have height of the tree over here, because this is going to be useful in our implementation of some other methods. So here I'm going to declare public int value. So in this case, our binary node will be the type of integer. So that's why the value of this node will be integer. Then I'm going to create another variable like this, public int height. So in this variable, we are going to keep the height of the node. Then we are going to create left and right child. So in this case, left child will be the type of binary node, and the right child also will be the type of binary node. Now, as we mentioned before, binary search tree is the binary tree. So in case of binary tree, we know that we can have at most 2 children in one node. So that's why we are declaring it left child and right child over here. Now, after finishing this binary node over here, I'm going to create a class which is for binary search tree. So here I'm going to create a new file and name it binary search tree.java. So inside this file, we are going to create our class over here, public class binary search tree. Then inside this class, we are going to create a variable for root node. So in this case, the type of variable will be a binary node that we created over here. So the name of variable will be root, in which we will have root of this binary tree over here. Now in the constructor, we are going to set root to null, because whenever we are creating an instance of this binary search tree over here, we are going to set root node to null, because in this case, we don't have any element in our binary search tree. So that's why root will be null. With this, we have successfully created our binary search tree over here. Now let's see how this is working in practice. So I'm going to create an instance of binary search tree inside main class. So with this, we are going to create our new binary search tree. So it's going to be like this: new binary search tree. So it's not taking any parameters. So with this, we can successfully create our binary search tree over here. Now if I run our code, in this case, it's not going to return anything, because we are just initializing the root node over here with the value of null. So running of our code will not return anything in this case. Now, as you can see, after running our code, it's not returning anything, because here we are just creating an instance of this binary search tree over here. Now let's see what's the time and space complexity for creation of binary search tree. In this case, when we are creating an instance of binary search tree over here, we are just setting root node to null. So in this case, it will take O1 time complexity, because this is a just simple assignment statement. So this one will take O1 time complexity. So this means that creating of binary search tree will take O1 time complexity. Now the space complexity is also O1, because in this case, we have not inserted anything into the memory. So that's why it's not taking any extra space over here. So that's why space complexity is also O1. Now with this, we have completed this lecture. So in this lecture, we have created a binary search tree in practice. So hopefully everything is clear about this lecture. Now in the next lecture, we are going to learn how can we insert a node to binary search tree. So see you in the next lecture.